Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel and press the bell icon to get the regular updates. Our today's topic for the lecture is polar and the non-polar covalent bonds. So let's start our today's lecture with a simple question. What does the word polar means? So I'm writing my first question over here. What do we mean by word polar? What do we mean by word polar? Polar stands for two opposite poles with opposite charges. So I'm writing polar stands for two poles with opposite charges, that is positive or negative charge. So whenever there is a charge separation, that is the formation of two poles with opposite charges in a covalent bond, then that bond will be regarded as polar covalent bond. So I'm writing, so whenever there is charge separation that is formation of two poles with opposite charges, in a covalent bond, in a covalent bond, then that bond will be regarded as polar covalent bond. So whenever there is charge separation in a covalent bond, that is the formation of two poles in a covalent bond, then that bond is called polar covalent bond. Let's take an example. I'm taking the bond between hydrogen and chlorine. In this bond, chlorine will acquire a delta negative charge and H will acquire a delta positive charge. So in this case, hydrogen is a one pole with a positive charge and chlorine is another pole with a negative charge. So in this bond, there is a charge separation. So this bond will be called as polar covalent bond. Polar covalent bond. The reason for charge separation will be discussed in the further lecture. Now, this phenomenon of charge separation in covalent bond is called polarity. So I'm writing this phenomenon of charge separation in covalent bond is called polarity. The word is polarity. So here one thing is understood, that there can be charge separation in a covalent bond, but the charge separation is a property of ionic bond. That means covalent bond also carries some sort of ionic character also. So I am writing charge separation usually occurs in ionic bonds. So, charge separation in covalent bond. Charge separation in covalent bond is the form of ionic character. Is the form of ionic character in covalent bond. And what is the exact meaning of polarity? So, polarity is the property which measures the extent of ionic character in covalent bond. So, I am writing polarity is the property that measures the extent of ionic character in covalent bond. Just like Fajan rule, which we have done in the previous lectures, just like Fajan rule, which measures the reverse of it, that is, which measures the extent of covalent character in ionic bond. Covalent character in ionic bond. Now let's talk about the polarity. I'm discussing about the factors on which the polarity depends. Polarity depends on electronegativity difference. Polarity depends upon electronegativity difference between the combining atoms. So, polarity is dependent on electronegativity difference between the combining atoms. So, to understand polarity more clearly, I am discussing about electronegativity now. What do we mean by electronegativity? Let's start. Electronegativity. It is the property of the element, or we can say it is the ability of the element to attract the shared pair of electrons, that is the bonds between, that is the electrons between the bonds. So it is the ability of the elements to attract the shared pair of electrons towards itself. So what is the shared pair of electrons? It is the electrons present between the bonds. So it is the, what is electronegativity? It is the ability of an element to attract the shared pair of electrons towards itself. That stands for electronegativity. Let's take an example of again hydrogen chloride. We are having hydrogen electron bonded with another electron of chlorine. In this case, the electronegativity of chlorine is much greater than the hydrogen. That is, chlorine is having higher ability to attract these both electrons, that is shared pair of electrons, towards itself. Due to which what's gonna happen? Due to which, I'm writing it again, hydrogen, chlorine, both the electrons will be more closer towards the chlorine. That's why chlorine will acquire a delta negative charge and hydrogen will acquire a delta positive charge. So it's the formation of two poles, so it's a polar bond. So I'm writing polar covalent bond, polar covalent bond with high electronegativity difference, or we can say the polar covalent bond is formed, the polar covalent bond is formed when there is high electronegativity difference, between the combining atoms, So the electronegativity of chlorine is greater than hydrogen. That's why chlorine has attracted the shared pair of electron towards itself. So chlorine is acquiring a delta negative charge and hydrogen is acquiring the delta positive charge. So it is the polar covalent bond which is formed due to the high electronegativity difference between the hydrogen and the chlorine. So hope you got this thing. Now let's talk about the factors on which the electronegativity depends. Electronegativity of an element is directly proportional to the effective nuclear charge more the effective nuclear charge, more will be the ability of an element to attract the shared pair of electron towards itself. And electronegativity is also inversely proportional to the atomic radius. Less the atomic radius, the smaller will be the atom, stronger will be the effective nuclear charge, and hence more will be the electronegativity, and hence finally more will be the ability of an element to attract the shared pair of electron towards itself. So we are having higher chances of formation of polar covalent bond. Now let's discuss about the trend of electronegativity in a periodic table. So I'm writing trend of electronegativity in periodic table. So let's talk about across the period. As we move from left to right across the period, the atomic radius decrease and the effective nuclear charge increase. So the electronegativity will increase across the period. Electronegativity will increase. I have made its detailed lecture in the chapter number 3 of atomic structure. You can check out the playlist and find that. Next, let's discuss about down the group. As we move down the group, the atomic radius increase, effective nuclear charge decrease, and hence electronegativity will decrease. Electronegativity will decrease. Now, we are having certain values of electronegativities of all the elements. I'm writing. We are having certain values of electronegativity of all the elements. In which the fluorine is the most electronegative and having the value of 4.0. Let me show you the periodic table with electronegativity values. So this is the periodic table in which the electronegativity values of all the elements has been mentioned, out of which the fluorine, you can easily see that fluorine is the most electronegative element with the highest value of 4.0. Now you can easily see that as we move down the group, the electronegativity value is decreasing. Electronegativity value is decreasing down the group, and as we move across a period, the electronegativity value is increasing. Electronegativity value is increasing. So, whenever there is a bond formation between two elements, we have to evaluate the electronegativity difference, and we are having certain ranges of electronegativity difference of bonds between the elements to assign whether that bond will be polar or not. So, let me give you that ranges. Now, firstly I'm writing the difference in the electronegativities. The difference in the electronegativity values of combining atoms or elements will decide the nature of the bond, whether it is polar or not, will decide the nature of the bond. So, let me give you the table for the ranges of electronegativity difference. So, I am writing starting with the first point. Here I am writing electronegativity difference. Here I am mentioning the nature of bond. In the next column, here we are having nature of bond, and at this point I will mention the examples. So, if the electronegativity difference is in the range of 0.02, 0.4, then that bond will be non-polar. For example, let's take an example of Cl2 molecule. Its bond will be like chlorine, single bond chlorine. What's the value of electronegativity of chlorine? Is 3.0. So here value is 3.0. The value for this chlorine is also 3.0. So the electronegativity difference for this bond will come out to be 0. So that's why this bond will be non-polar. That means in this bond, chlorine bond chlorine, there will not be any charge separation. Now let's come to the second point. If electronegativity difference is in the range of 0.5 to 0.9, then that bond will be slightly polar. Slightly polar. For this, I am taking the example of hydrogen chloride, HCl. Here's H bond Cl. The electronegativity value for chlorine is 3.0 and that for hydrogen is 2.1. So the electronegativity difference for this bond comes out to be 0.9. So this bond is slightly polar. Now let's come to the third range. If electronegativity difference is from 1.0 to the 1.3, then that bond is moderately polar. So then that bond will be moderately polar. For this, I am taking the example of bond between carbon and oxygen. So I am writing carbon bond oxygen. The electronegativity value for oxygen is 3.5 and that for carbon is 2.5. So here electronegativity difference for this bond is 3.5 minus 2.5 comes out to be 1.0. So this bond is moderately polar. Now let's come to the fourth range. If electronegativity difference is in the range of 1.4 to the 1.7, then that bond will be highly polar. For this case, I am taking the example of bond between oxygen and hydrogen. So that's the oxygen, hydrogen. What's the electronegativity value of oxygen is 3.5 and what's of hydrogen it's 2.1. So the electronegativity difference for this bond will come out to be 3.5 minus 2.1, that comes out to be 1.4. So this bond is highly polar. Now let's come to the fifth case. If electronegativity difference is in the range of 1.8 to the 2.2, then that bond will come under the ionic bond and it will be slightly ionic. For this, I am taking the example of hydrogen fluoride, HF. That's hydrogen bond fluorine. What's the electronegativity value of fluorine? It's 4.0 and what's that of hydrogen? It's 2.1. So the electronegativity difference for this bond will come out to be 1.9. So this bond is slightly ionic, or we can say in this bond we are having higher charge separation. The extent of charge separation is very high. And finally, let's talk about the last range, 2.3 to the 3.3, and this bond will be highly ionic. So I'm talking about the ionic bond now. Let's take an example of sodium fluoride. That's bond between sodium and the fluorine. It is completely ionic, Na positive and the F negative. Was the electronegativity of F is 4.0, and was that of sodium, it's 0.9. So the electronegativity difference comes out to be 3.1 in this case. So the bond between sodium and fluorine is obviously ionic bond. So at last, let me tell you about the nonpolar bond. The definition of nonpolar bond is left. Let me write that for you. Nonpolar bond: when there is not any charge separation, when there is not any charge separation in a covalent bond. In a covalent bond, because the difference in electronegativity is almost zero between the combining elements. So I'm writing because the electronegativity difference between the combining elements is zero, or we can say almost negligible, then that bond is purely covalent bond. We are not having any ionic character in it, or we can say the pure covalent bond is actually non-polar bond. That means I'm talking about the very first case when the electronegativity difference is in the range of 0.0 to 0.4. So that's all about the polar and the non-polar bonds. The polar bonds were dependent upon the electronegativities, and electronegativities were dependent upon the effective nuclear charge and the atomic radius. Then the extent of polarity was dependent on the electronegativity difference of the combining elements. More the electronegativity difference, more ionic character will be there, or more polar bond will be there. If the electronegativity difference is negligible or nearly zero, then that bond will be non-polar or pure covalent bond with a 100% covalent bond character. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Press the bell icon to get the regular updates. Don't forget to press the subscribe button. Stay blessed.